Hi students, we were talking about the electron structures of carbon and the versatile nature of carbon in the previous video. So we'll continue with the versatile nature of carbon in this video and we'll do the nomenclature also. Okay, so here versatile nature we learned that carbon has got a tetravalency and catenation, two properties make it so versatile. In addition to that, carbon also bonds with other elements such as halogens, oxygen, nitrogen, sulfur, etc. And in a hydrocarbon chain, one or more hydrogens are replaced by these elements. The element replacing hydrogen is called the heteroatom. So, carbon combined with the heteroatoms like sulfur, oxygen, nitrogen, etc. Okay, and in some cases, the heteroatoms or forms a group, okay, containing, and this gives a special property to that compound. For example, here in this picture shows that carbon is joining with oxygen, but OH is forming a group, okay, which determines the or it contributes special property to this compound, and we call this group as a functional group. Okay, so in this topic we'll be talking about functional groups. We have to study certain functional groups which are given in the text. In that, it is given chloride or bromide. But when it is coming to functional groups, it comes as a prefix. That means when you name the compound, we'll fix this as a prefix, the name of this compound, this functional group as a prefix. For example, chloro. If bromine is attached, we'll call it bromo, like that. Okay. And there is another functional group called alcohol, and the functional group is OH. The single line shows the single line here it is showing the valency of the group, functional group. For example, OH can be replaced by a single hydrogen. Chlorine can be replaced by a single hydrogen. Okay, bromine also, like that. And next is aldehyde, CHO. Okay, CHO is the functional group. It is called aldehyde. Then it is ketone, C double bond O, ketone. But see here it is two valency. Valency is it is a bivalent. Okay, we can substitute this by removing two hydrogen atoms only. Okay, because the valency is two here for ketone. Carboxylic acid is valency is one. So formula is COOH. Okay, carboxylic acid. So these are the functional groups you have to study which are given in your text. Okay. Now we'll talk about homologous series. Homologous series. Okay. So here a functional group such as alcohol decides, we already said, it decides the properties of that compound. For example, see this compound, this third, all the compounds are having an OH group, functional group present. Okay. And what is special about that? They shows similar chemical properties. Their chemical properties are very much similar. Okay, that means this functional group it decides the property of that compound. Okay, such and see this is a series of compounds having OH group in it, and each group differ by a CH2. Okay, such a series of compounds in which the same functional group substitutes for hydrogen in a carbon chain is called a homologous series. So this is the homologous series of alcohol. Okay, C3OH, C2H5OH, C3H7OH, C4H9OH. These are coming under the homologous series of alcohols. And what are the specialities of a homologous series? Uh, they differ by a CH2 group. Each consecutive member, okay, each consecutive member or succeeding members differ by a CH2, or we can say by a difference of 14U in molecular mass. Each consecutive member, each succeeding member differ by a 14U molecular mass. Okay, for example, if you take the homologous series of alkanes, okay? Starting with CH4, then CH2H6, then C3H8, C4H10. Okay, CH4, C2H6, C3H8, C4H10. This is the homologous series of alkane family. Okay, and see each member, succeeding member differ by a CH2. Okay, and it this since the arrangement is somewhat similar, it shows similar properties, chemical properties. Okay, so such a series is called a homologous series. Okay, which are having similar chemical properties but differ by a CH2 or a 14U molecular mass. Okay, now we'll talk about the homologous series of alkenes. What is special about alkenes? We'll talk about. Okay, it will be having a double bond in their compounds. We'll study that. Okay, the first member is ethene. It is not a compound with one carbon because we need a double bond between two carbon. So minimum two carbons are required for the this type this series. Okay, that means ethene family. See, the first member is C2H4, then C3H6, C4H8, C5H10, like that it goes. But in that case also the difference is by a CH2 group. Okay. Then if next it is alkynes. Okay, alkynes, also the first member is C2H2. Okay, so first member is C2H2, and we can represent these three series by a general formula. For alkanes it is CnH2n plus 2, where n stands for the number of carbon. If n is 1, it is CH4, like that. CnH2n is the general formula for alkenes. Okay, alkenes. Whereas it is CnH2n minus 2 is for alkynes. Okay, and we can see that as the molecular mass increases, means the number of carbon increases, the melting and boiling points, solubility, etc. also increase. Chemical properties remain the same. Okay, that is special. That is what is special about homologous series. Each consecutive member differ by a CH2 or their chemical properties are the same, similar, very much similar, but the physical properties increases with the increase in the molecular mass. Okay. Now, homologous series of alcohols. See, homologous series of alcohols, it is showing here CH3OH, first member, second member, third member, fourth member. Carbon 1, 2, 3, 4, 5, like that. Okay. There are also the differences by CH2. This is the homologous series of alcohols. Okay. We'll be having all the compounds will be having similar chemical properties, but physical properties vary according to the molecular mass. Okay. Now you can study how to give name for a carbon compound. That is what is called a nomenclature of carbon compounds. Nomenclature of carbon compounds means naming of carbon compounds. How can we name a carbon compound? Okay, for that, see, it is given some examples. For example, if there is a functional group carboxylic acid present, we'll add a suffix oic acid into the name of the compound. Okay, then what we have to study is aldehyde. For you it is aldehyde only coming. Aldehyde, it is, we will add a suffix al. Okay, for ketone we'll add a suffix one. For alcohol we'll add a suffix oil. Suffix means name at the end, coming at the end. For amine we don't have to study it. Okay, this only. Then there is halogen. Halo is coming as a prefix, not as a suffix. Only halo is coming as a prefix, means starting with the halo. Chloro, or it can be chloro, bromo, like that. Okay, then we'll study how to name. Okay, we'll taking few examples. For example, see here it is given a compound with a mm, 3 carbon. So first step to name a compound is name the number of carbons present. What is it? It is 3. Okay. So 3 stands for prop. Okay, I'll tell you. For example, it is see for example, if carbon, okay, carbon atom, if it is 1, it is, we'll use meth. 2 carbon, eth. 3 carbon, prop. 4 carbon, but. 5 carbon, pent. Hex, hept, like that it goes. Okay. Then if there is a single bond only, an. Double bond is there, en. Triple bond is there, yn. Okay. This is what you have to keep in mind first. So when you get a compound, first we'll count the number of carbon. It is 3. So we'll write the letters 3, prop. Okay, prop we are writing. Then we'll check for functional groups. Okay, we'll check for it is, there is a chloro group present here. So we'll add the suffix chloro. Okay, we'll add the suffix chloro. Then we'll check whether there is a double bond or triple bond or single bond. Okay, here everywhere it is double bond, single bond only for carbon carbon, between carbon carbon only single bond. If that is the case, we'll add the letters an. Okay, we'll add letters an to the name. Okay, then everything over. Then we'll end the compound name with an e, like that. So the name is chloropropane, like that. Okay, now the second next compound is this. We'll count the number of carbon 3. So the letters prop. First letter should be capital. Okay. Then we'll check for functional group. No, before that we'll check for a double or triple bond. That is all single bond. So we'll add the letters A. Okay. Okay. Then we'll check for functional group. It is OH group. So we'll add the suffix OL. Okay, that is how the name propanol. Now see, we'll check the number of carbon. Next compound, okay? It is 3. So it is prop. We wrote the letters prop. Then we'll check double bond between carbon carbon. No, all single bonds only. So we'll add the letters N. Then we'll check for the functional group. Here the functional group is CHO, aldehyde. So we'll add the suffix al. If it is aldehyde, the suffix is al. So the whole name is becoming propanol. Okay. Now the next compound is number of carbon 3. That means prop. Okay. Then check for double or triple bond between carbon carbon or single bond only. So the letters AN. Okay. Then we'll check for functional group. Of course, there is a functional group called a ketone here. So if it is ketone, the suffix ON. We'll add the suffix ON. So we got the name propanone. Okay, we got the name propanone. Okay. Now the next compound 1, 2, 3 carbon. That means prop again. Then no double or triple bond. So the letters AN. Then we'll check for the functional group. The functional group here is C double bond OOH. That means COOS, carboxylic acid. If carboxylic acid is the functional group, the suffix oic acid. We'll add the suffix oic acid. So the name propanoic acid. Okay. See this. I'll count the number of carbon 1, 2, 3. Again prop. Okay. Then we'll check a double or triple bond. Of course, there is a double bond present. So we'll add the letters En. If it is double bond, the letters En. Okay. So we'll add the letters En here. Then no functional groups present. So we'll end the compound name by adding an E. Okay. If there is no functional group present, we'll end the name of the compound by adding an E. So the name of the compound is propene. Okay. Now it is this one. 1, 2, 3 carbon. Again prop. Okay. Check for double or triple bond. Yes, there is a triple bond. So we'll add the letters YN. Then we'll check for a functional group. No functional group present. So we'll end the name of the compound by adding a letter E. So the name of the compound is propyne. Okay. So that is how we name the compound. Okay. Now, next, we'll be talking, we'll be doing some examples, okay, in the board. We can do a few examples in the board. Okay, we can use so for example we have a compound which okay it will be having only one carbon. It is having only one, so we wrote meth. Okay, meth. Then we'll check whether there is a double or triple bond. No, it is all double bond. Since it is showing like this, it is no double bond possible here. Okay, now the functional group is OH. So we'll add the suffix ON. So the name of the compound is methanol. Right? Now we have, you can write like this. It is like this. Okay, everywhere it should be filled with the hydrogen like this. Okay, now we'll check number of carbon. It is 3, so it is compound is prop. Okay, now what, we'll check for double or triple bond. All double, single bond only, so we'll use the letters AN. Then we'll check for functional group. The functional group here is Cl, so we have to add the prefix chloro. Then this P should be small, chloropropane. Okay, the P should be small here. Should can remove it. It's okay, chloropropane. Chloropropane is the compound. Okay, is the compound name. Like that. Then we will do what? It is 1, 2, 3, 4, 5. It is 5 carbon. Okay, there is a functional group here. Okay, all others it is hydrogen. It is hydrogen. So we'll check now, count the number of carbon. It is 5. So we'll write the letter or letters pent. Then we will check for double or triple bond. Always single bond only here. No double bond between carbon comes, so pentan. Then comes, we'll check the functional group. The functional group here is C double bond O. That means ketone. So the suffix O N A. So the compound is pentanol. Like that. We can add name into what? We can give name to the compounds like this. Okay, so with that we are ending the topic today. We will discuss the next topic in the next video. Thank you.